Yeah, so continuation of question B. We're finding the minimum value. So we had 3 minus 16 over 4, right? Then you say 4 into 16 is 4. Then here you have to be careful of signs. A lot of people make mistakes. So signs, so we have different signs. This is positive 3 minus 4. So different signs, you always subtract and get the sign of the greater number. So 4 minus 3 is a 1, but the sign of the greater number is a negative. So you have negative 1 as your minimum value. You're done. So we have this question, the speed time graph. That's the question there. Okay. So the question reads, the diagram below is the speed time graph of a car. The car starts from rest, meaning from 0. So this is your diagram like that. Then you have that. So you have time in your x-axis here. Then in your y you have speed there. So there's 16 there. Okay. So from rest near Papa 0 there, the initial point here. Then you have t there. So this is time, this side you have time. Okay. Then they're saying this the car starts from rest 0 there and accelerates uniformly at 2 meters per second squared for t seconds. So this period, t seconds. So acceleration is this part here. So this part represents acceleration. So it's increasing like that. So acceleration. Then if it's decreasing like that, going downwards, that's deceleration. Okay. Reduction in speed, then increase in speed, which is velocity. Okay. Increase in velocity, acceleration. So what we're going to do, we are saying 40 seconds this time until it reaches a speed of 16 at this point. Then it then travels at 16 meters per second for 40 seconds. So meaning from here t until this point here for 40 seconds. So from there to there it's 40. There's a 40 seconds period here. 40 seconds period. Okay, 40 seconds. Then they're saying travels 40 seconds, after which it comes to rest in a further 10 seconds. So meaning from this point to that point, there's 10 seconds here. At this period, there's 10 seconds, okay? So what we're going to do now, the first question, they want us to find the value of t. So to find the value of t here, we simply use the acceleration that we've been given, because we've been taught during this period of t seconds, it accelerated, okay? There's acceleration. So acceleration is equal to final velocity minus initial velocity over time taken. So v is the final velocity, this is the initial velocity. So acceleration, we have 2 meters per second squared. Then final velocity, this is the final speed. So we have speed this side. So we have speed this side, speed. So this is the final velocity. Here 16 speed, meters per second. Meters per second, speed 16. That's your final velocity. So velocity and speed, they've got the same units, okay? So then final 16 here, then initial per rest up when it started, which is 0. Then the time it took, which is t seconds. So you put the t there. Then you say 2, 16 minus 0, you have a 16 over t. Then you cross multiply at this point. Then 2 times t, you have a 2t. Then 16. Then over 2 both sides. Then you divide out. So t is equal to 2 into 16, which is 8. Half of 16 in short, which is 8. Now t is time, so 8 seconds. So in short, it took, in the 8 seconds, it accelerated from 0. After 8 seconds, it's accelerated for 2 meters, is it second squared? 2 meters per second squared. So this is our t, the value of t, which is time, 8 seconds, okay? Then remember, we've been taught to say after 8 seconds, since we have t8 here, so we can put the 8 there, so it's 8. Then this car traveled for further 40 seconds. So in short, we say 8 plus 40, you have 48 here. So in short, there's a 48 there. Then from here, we were told it traveled for further 10 seconds. So 48 plus the 10, you will have a 58. So at this point there's a 58 there. Okay, so in short, the total time for this car, it traveled for 58 seconds, the total time. Okay, yeah. So B, they want us to find the distance traveled in the last 50 seconds. So the last 50 seconds, what you need to understand, distance is simply the area under graph. Okay, okay. So I was saying distance is simply the area under the graph. So they're saying the last 50 seconds. So from here, this is the first 8, then the last 50, this is 58. 58 minus 8, you get a 50. So the last 50 seconds is this portion here, this part. So we find the area under this part. So this shape formed is a trapezium. So we need to find the area of a trapezium. So area of a trapezium will give us the distance in the last 50 seconds, which is half A plus B height. Okay, so you need to identify the A, B, and the height. So your A is the distance from there to there, this distance. So this distance here we have 8 there, here there's a 48. So we say 48 minus 8 will give you your A from there to there. So 48 minus 8 will give us 40, right? Give us a 40. So we have 40 there, plus B is the distance from there until the last part here. So which is 58 minus 8, which will give us a 50. Then the height is the part from there to there. This is the height. So you take a look at this side. 16 there. Here there is a 0. So 0 to there, which is 16. So your height is 16. I mean 16. Your height is 16 there. So multiplication doesn't matter the order. So you can say half of 16, which is 8. Then 40 plus 50 will give us a 90. Then 90 times 8 will give us, so you say 8 times 0 will get 0. Then 8 times 9 will get 272. So 720. Since what we're looking at is distance, then the units are meters, so 720 meters. So the distance traveled in the last 50 seconds is 720 meters. Okay, because 90 times 8 will give us 720. Give us a 720. Yeah, so C, they want us to find the speed of the car when t is equal to 53 seconds. So if you look at, we found to say here there's 8, 48, 58 there. So 53 is between 58 and 48, somewhere there. So just approximate. So 53. So now 53, speed is this side, y-axis. That's why we have speed this side. So we want to find when t was 53 at this point, somewhere between. So you say dotted on top until you bring it to this side where you have your speed. So now what you need to understand, when the line is slanting like this, going downwards, this is deceleration, a decrease in velocity or speed. Okay, deceleration. So we need to, the deceleration here is uniform, it's constant, it's uniform. So in short, we need to find the deceleration at this point when the t was 58 and t 58 here. So we find the deceleration for this portion here. So deceleration is negative. You just get the formula for acceleration, you put a negative, and then you're finding for deceleration. Okay, so it's a negative. So final velocity, since it was reducing speed, this is the initial point here. So initial point, velocity, which is speed, was 16. So you put 16 is the initial, then it decelerated until it reached this part. So now this point here, the last point, when you check the speed, you go speed, it takes you to 0. So the final speed was 0. So final is 0. Initial was 16 at start here. This point 16. Then time it took from this point until that point. So here we have 16 initial speed. You come down, it brings to 48. Then 48 to 58, the time here between to this point. Say 58 minus 48 will give you a 10. So you have a 10. so it took 10 seconds. And say negative 0 minus 16 will give you a negative 16 over 10. Then negative times negative, you get positive. So you have 16 over 10. 16 over 10. Okay. So we'll keep it as 16 over 10 for now. So this is our deceleration, which is 16 over 10 meters per second squared. We'll keep it like that for solving purposes. So since we said the deceleration is uniform along this point, so at that when t was 53, the deceleration it was also 16 over 10. Okay, so we're going to use this same deceleration, 16 over 10. So we're going to say deceleration, which is negative v minus u over t. So deceleration, which is 16 over 10, then negative. So v, final velocity is at this point, which is 0 still. So okay, final velocity, which is 0 still. Then initial, it's this point here. So actually the final velocity, it's not actually 0, it's what we're looking for here at this point when t was 53, the velocity, which is speed here, that's what we're looking for. So we can just write as speed time. You can use any data. Then initial, it's this point up, so which is 16. Okay, then our t will be the time. So 53 minus 48 here, this portion here. So we're at 53 minus 48. 53 minus 48, you have 5. So 5 there. Then 16 over 10. Then s minus 16, you keep it like that. So you can just say negative times s, we have a negative s. Then negative times negative, positive. So 16 over 5. Then you cross multiply at this point. So you cross multiply. So you have 16 times 5. Since it's per power, just write it as 16 times 5. Then you write this as 10 times negative s plus 16, like that. And say over 10 over 10. Then divide out. So 16 times 5 over 10. Then negative 5 plus 6. Negative s, what we're looking for. Then you say 5 into 5, 1. 5 into 10, 2. Okay. Then 2 into 2, 1. 2 into 16, 8. So you have 8 is equal to negative s plus 16. Then you do, we're looking for s. So this s has to be a positive. So we take the s this side. Then the number goes that side. So 16 minus 8. So s will be 16 minus 8, which is 8. Not 8, sorry. 16 minus 8 will give you 8. It's actually 8. Sure. So 8. So this 8 is our speed when t was 53. So speed units is meters per second. Okay, don't write squared. No, that's for acceleration or deceleration. So meters. Don't forget the units. Very important. Okay, so 8 meters. So we are done.